All right, welcome to another Mr. X free Zoom lesson, and we are tackling mathematics today. We are going to be talking about completing the square as well as tangents of a parabola. That's what we're going to be talking about today. So I'm going to help you guys to understand this very basic and very important concepts in mathematics. I'm going to share the screen quickly and start off with some exciting news that I have here. All right, so there we are. What am I doing? So starting from next week, I'm going to be doing Zoom classes, group classes for Zoom starting next week. These will contribute to mathematics and physical science, which is what I specialize in, and they're starting next week. So these are group classes. All of them are online, similar to what we're doing right now. So they include, or I'm offering, comprehensive teaching of grade 12 mathematics and physical science. And remember that each particular session will be 2 hours long. All the sessions will have exam-centered answering techniques and various past exams that we're going to use. I'm going to teach you to understand, teach you to pass, and all the teaching there will be student-oriented. Unfortunately, though, I have a maximum number that I can take. I can only take 50 students at a time, so there's limited space. Hence, I said, book your spot now. It's 150 rands for a 2-hour session. So that means that if I teach you for 2 hours maths, one topic, and then again physical science, 2 hours another topic, then that means it's going to be 150 for each particular topic or each particular subject. I'm going to be doing this particular lessons once every week, just once every week. So I'm going to do them one day for maths and then another one day for physical science, so once every week for each. So that means if you're doing maths and physical science and you'd like to be involved, you can come for 2 lessons a week, but all of them strictly are going to be online. So you guys can contact me on my number 0739748498 to book your spot. Follow me on my socials, where I've got my YouTube page, which is Mr. X Mathematics and Physical Science, grade 12. And then also you can follow me on Instagram, which is under Mr. X Maths Science. All right, perfect. That's as far as we go. Let's get down to beautiful business. Don't forget this. I'll share this again towards the end of our lesson. All right, what are we doing today? Today, we're talking about completing the square. That's what we're talking about today, completing the square. To complete the square is a method used to compute quadratic polynomials by changing the form of the equation from the standard form. Let me explain what that means. Basically, when you're dealing with a quadratic equation, the standard form of a quadratic equation is this one. F of x is ax squared plus bx plus c. Sometimes if you want, you can write it as y is equal to ax squared plus bx plus c. This is the standard form of a quadratic equation. But I want you to understand that this particular standard form can be written in other forms. You can write it in what is called the root format. So the root format. In the root format, you're saying y is equal to a, then x minus x1, then x minus x2. This is the root format. I want you to understand that when you want to move from the standard format, which is what you have here, to the root format, all you need to do is basically to factorize. So if you're given a quadratic equation and you're asked to write the root format, just factorize. So who is this x1 and x2? x1 and x2, these are your x-intercepts. Or if you want to put it nicely, these are your roots. The x1 and x2, these are your roots. So imagine this standard form as the mother, then the root format as the firstborn child. Now there's a second-born child in this family. So you can move from the quadratic to the root format, firstborn child, or you can go to the second-born child, which is the turning point format, which is what our lesson would be about today. The turning point format like this. Now, the turning point format To move from the mother to the turning point format, all you need to do is to complete the square. That's what you need to do. You complete the square. Notice, a typical quadratic equation or a quadratic graph, to be specific, would have your Cartesian plane there, and maybe you put your graph somewhere there. So let me just continue with that line to make it clear. This will be a quadratic graph. And then this particular point here, this point here is a turning point, or if you want, you can call it a stationary point. The x coordinate of the turning point is P. The y coordinate is Q, which we find in the second bond chart. So when you're completing the square, you're changing the quadratic equation from a standard format to a turning point format, whereby you can be able to see your P, which represents the x coordinate of the turning point, and the Q, which represents the y coordinate of that particular turning point. Now, having said that, it's then important to understand, how do we complete the square? What are the steps in completing the square? All right, let's go through a typical question here. How do we complete the square? So here's a question. Example one, I'll do about 4 examples. Example one, we'll start off with something small, then we take it up from there. The question says, given the equation, this one, x squared plus 6x plus 7. Now, notice that this is a quadratic equation. You can come with a quadratic graph from that equation. The question says, write down the function of f in the form f of x is equal to a, x minus p squared plus q, using the completing the square method. So what are the steps? Step number 1. When you're given your quadratic equation, factor out the coefficient of x squared in the quadratic expression to ensure that the coefficient of x squared is equal to 1. Very important. So if you're given a quadratic equation, the first thing is to ask, is the coefficient of x squared equal to 1? Yes. If not, then factor out that particular coefficient. Judging by the question that I'm having on the board here, the coefficient of x squared in this case, luckily, is 1. So there's no need to factor out. So step number 1, all we have is just this noticing that the coefficient of x squared is 1. Just as a heads up, the coefficient of x squared is the number multiplying x squared. So this is my x squared right here, and the number multiplying x squared is 1. It's a ghost 1. We don't see it. It's a ghost 1, that one there. Step number 2. Take the coefficient of x in the new quadratic expression, okay? Divide it by 2, okay? Square it, add and subtract it in the expression. Now that's a mouthful, but we can do this together. Let me go step by step. They say to me, take the coefficient of x in the new quadratic expression. So I'm here right now. So I'm going to rewrite this as f of x, okay, is equal to, I'm writing x squared, then plus 6x. But I hear something. Take the coefficient of x in the new quadratic expression. All right. Divide it by 2. Square it, add and subtract it in the expression. So I'm going to take the coefficient of x. All right. I'm going to put a plus because they said add. Right? Take the coefficient of x, which is 6 in this case. Then I'm going to divide it by 2. All right. Then I'm going to square it. So they said, take that coefficient, divide it by 2, square it, add, and then they also said subtract it. So I add and subtract. So my expression so far, I've written up to this point, x squared plus 6x right there. Then I added the coefficient of x, 6, divided by 2 squared. Then I'm going to write plus 7. Then it says, and subtract it. I'm going to go further. Minus who? The coefficient of x, which is 6, divided by 2, then square it. Let's go back to this rule. What's going on in here? Take the coefficient of x. I took it 6. I divided by 2 there. I squared it. Then I added. That's a plus. Then I took the same guy, coefficient of x, 6. I divided it by 2. I squared it. But this time I subtracted, not forgetting my 7, my constant term. That's as far as I have in rule number 2. Take the coefficient of x again, divide it by 2, square it, add and subtract it. Okay, so that's rule number 2. Then what after that? Then what after that? Let me go to rule number 3 to explain to you what happens. All right. Rule number 3, the last one says, then factorize the expression and rewrite it in the form a x minus p squared plus q. So far, what do we have? So far, I know that f of x is equal to x squared, all right, plus 6x. I add coefficient of x divided by 2 square. Then there's that plus 7. Then I subtract. Then I've got 6 over 2 squared. We need to factorize. So how do I do this? Look at this particular expression, this one here. Start with this. It's very easy to factorize. So you look at this expression here, and then you put an x right there. Then what? Take the number in the bracket and its sign, but don't square it. One more time. Take the number in the bracket. Which number? 6 over 2, which gives me a positive 3. Take the number in the bracket and its sign, but do not square it. So I'll take 6 over 2. Then I'm going to say, okay, it gives me a 3. I'm not going to square it. Then I put plus 3 here, then the squared outside. Then the squared outside. Very important. Then lastly, deal with this guy. Deal with this guy here. This one, you're simply going to put this in the calculator. Plus 7 minus 6 over 2 squared. And your final answer is now minus 2. Now you can check your equation. It now gives me a situation. It's now written in the form a, all right, x minus p squared plus q. The intention was to change from the standard format into the turning point format. And in all these situations, notice that you're completing the square. Take the coefficient of x, divide it by 2, square it, add, and subtract. Then the last statement says you must factorize. And I just gave you a hint here. I said, take this expression here for what it is. Open your brackets, x, then close your bracket, and then take the number in the bracket, this one, 6 over 2. Don't square it. Do not square it. Take it as it is. 6 over 2, that's plus 3. Then close your bracket, squared. Then deal with this guy. It gives you an answer of minus 2. Eventually, your particular equation is now in the form f of x is a, x minus p squared plus q. So you've turned from a quadratic standard form to a quadratic turning point format. Interestingly, listen to this. Interestingly, if you want to go back to the standard format, if you want to go back to a x squared plus bx plus c. All you need to do is just open up the brackets. That's all. You just open up these brackets nicely, you'd get back to the same thing. All right, so that's our first example, a very simple one. Let me just get a bit more and do a bit of a challenging one as we're going along. Again, the idea is to complete the square. I'm hoping that you guys are understanding. Then if you don't understand, you just lift up your hand and I can help you. Somebody has a hand up. I've just unmuted you.
Hi, sir. Can you hear me?
Loud and clear.
You know, the example you just did now, when you take it from the standard form to the turning point form, what happened to the 6x over there? Because I don't see what you did to it to get to the turning points format.
To the 6x, well, I took the 6x, let me just clarify this. There's 6x there, so it's x squared plus 6x plus 7. And then I did rule number 2, where I said x squared plus 6x is still there, plus, and then 6 over 2 squared, and we go through this, minus 7 plus 6 over 2 squared. Then for me, the key was factorizing this. That was the key. And when you do that, you end up with x plus 3 squared. Like I said, take the number in the brackets, don't square it, and then minus 2 at the end of the day. Eventually, when you open up, you're going to get back to the same point, and eventually to the same point when you open up every single thing.
Thank you.
That's what happens. All right, perfect. I want to do another question there. I see some hands here. Allow me to do another question, and I'll come back to you guys quickly. Maybe you'll understand more when I've done the other question as well. Just hang in there. I want to do another question. Here's a question example 2. And it says, given f of x is minus, this time the coefficient of x squared is negative. And the rule says if the coefficient of x squared is not 1, factor out. So when I'm factoring out here, all I'm doing is I'm saying to myself, f of x, first step, minus, okay, is equal to minus, I'm factoring out. So that becomes x squared minus 4x minus 5. I've taken out the negative 1. Perfect. Now, it says then, write down the function in the form f of x is equal to this, and hence write down the coordinates of the turning points. Very important. So now that I've taken out the negative, I will do the rules. So what do? Take the coefficient of x, all right, add it, divide it by 2 rather, square it and add it. So the coefficient of x is minus 4. I've just divided by 2, squared it. Then I put my minus 5. I continue. Then I subtract again. That becomes negative 4 over 2 squared right there. All right, I'm hearing that I'm supposed to deal with this guy first. The negative is still outside. I see that. Then now I'm going to write it as x, then close bracket, squared. Again, take the number in the brackets, don't square it. Take the number in the brackets, don't square it. Minus 4 divided by 2 is definitely minus 2. Then I'm going to sort this guy out at the end. In other words, it's minus 5 minus bracket minus 4 over 2 squared, which leaves me with minus 9. All right, beautiful. So that's what I have so far. We still have a negative 1 on the outside. Now I'm ready to write it in the format that I want. Now, the negative will multiply this part and also multiply that part. Eventually, this becomes negative bracket x minus 2 squared plus 9. Negative x minus 2 squared plus 9. So the negative multiplies here. But remember, there's a squared, so the negative would just be hanging outside here. But negative times negative will give you a positive 9. And at the end of the day, when you're now saying what are the turning points, you're comparing. So you're comparing to the turning point format like this. So I'm going to pick up who is who. First things first, my A in this case will be -1. Perfect. Then my P in this case would be a +2. And finally, my Q will be the +9. So I've just picked out my A, my P, and my Q. But the question was just asking about the coordinates of the turning point. Earlier, I'd say to you guys, the coordinates of the turning point basically will be P and Q, 2 and 9, X and Y. So you've converted this particular standard form into the turning point format. Again, if you were to open up the brackets, you'd get exactly to that particular point, exactly. So from the standard form to the turning point format, you complete the square. From the turning point format to the standard form, all you're simply doing there is you're opening up the brackets and foiling, adding, subtracting. That's just basically your algebra right there. Right, I'm gonna just unmute a couple of hands. People have questions. Go ahead. I've just unmuted you.
Hi, sir.
Morning.
Can you hear me?
Loud and clear.
So my question was actually what you explained, like what would you have done if you have your coefficient as a negative?
Oh, okay.
I wanted to understand how to do it, but you just done it. Thank you.
All right, perfect. Good. Thank you so much. All right. I'm going to go to my next hand right there. I'm asking to unmute you.
Morning, sir.
Morning. Hi.
Good. Can you hear me?
Loud and clear.
Okay, so I wanted to ask about, in terms of what you're doing, I use the turning point formula, the one that says -b/2a, right?
Yes.
So when I use that, I subbed in what was given on the quadratic formula, and I subbed in that, it gives me -3 and -2. So how I get the P is that I formulate P in terms of x minus P is equal to 0. Then I put in the number that I've got where P is, then it's going to be x is equal to that certain number.
All right, perfect. So you've just told me about another method of actually finding the turning point, and that's okay, that's fine. This method, you can use it when you're asked to just write the turning points for what they are. But if you notice the question, they said you must write it in this format. So I agree with you. You can use the x coordinate of the turning point as -b/2a, get your answer, put it back into the original equation. Then from there on, you can be able to get your particular y coordinate of the turning point. Remember that I'm just specifically zeroing in to completing the square. So I want to teach you guys how you actually complete the square of a quadratic, but that's a very good method that you just put along in that line. All right, so let me try the next one. Thank you so much. Let me try the next person there. I'm going to unmute you quickly, and I want to move on to my other question. You're unmuted. All right, now I can't pretty much hear you. Let me try the next one. That's the last one, then we move on to another question. Go ahead.
Hi, sir. Can you hear me?
I can hear
you.
me,
Sir?
Yes.
Okay. I actually have 2 questions, but can I start with the first one? So just before, in the last step, actually, where you have negative in brackets x minus 2 squared plus 9. So I just wanted to know, since you multiplied the negative to -9 and you got a positive, why can't you just also multiply the negative in the -2 so that the 2 becomes positive?
All right,
like
perfect.
we're going to negative x plus 2.
Good question. It's because the x minus 2 has a squared. So you can't do that. You can't say minus x minus 2 squared is minus x plus 2 squared. This will be wrong mathematics. So you can't multiply because the x minus 2 is an expression with a squared. In fact, you would need to first open up x minus 2 squared. That's board mass, right? Open up the brackets first, and then after that multiply by negative. So you can't do that unless and until you open x minus 2. Then after that, you can multiply by the negative 1. Is that okay?
So, and
Second
yes,
one?
can I help you? Okay, second question is that if I was asked to identify the turning point, if my equation didn't have a negative sign, like a negative coefficient of x, was I going to be correct if I said that my turning points are -2 and 9, if
All
I
right.
didn't have a coefficient?
Okay, so are you saying if it's written like this, x plus 2 squared
No.
and then
No.
-9? Are you saying this way?
No, if it was written x as x minus 2 squared plus 9, will I be correct if I said my turning points were a -2 and a +9?
No, you would
Yes.
not be correct. Okay, thank you for that beautiful question. Okay, so let me just take this out and clarify this. Thank you for that. So the original format is ax minus p squared plus q. And in what I'm doing, I've got this particular situation plus 9. Now, in some books, they write it in this format, which is still fine, but please remember that you must negate the p eventually. So I prefer this one. It's easier to understand. So look at this. It's x minus p, then it's x minus 2. Now, if you're struggling, just say minus p is equal to -2. Minus p is equal to -2. That means p will be 2. If you're struggling, plus q is equal to +9. Plus q is q, plus 9 is 9. So q is equal to 9. Basically, that's what you do. So x minus 2 squared plus 9, p will be 2, while q is 9 on the other side. So that's what you do. To an extent that if I say to you, let me just try and see if I can come up with another example. If I say to you, this will be the standard format of the turning point, and then I put -2, then I say x plus 3 squared minus 7, and somebody says, write down the coordinates of the turning points. So check, minus p is equal to +3, so that means p is equal to -3. Then plus q is equal to -7. That means q is equal to -7. So this becomes your turning points in that particular aspect. So that's what you do eventually as we go on along. All right, allow me to move on. Thank you guys for this wonderful questions that you guys have. Let me move on to another example. Here's an example, and I took this from a past exam paper, the 2017 IEB paper, March paper 1, question 6a. So I adapted it from there. It says to me, f of x is equal to that. Rewrite the equation in the form f of x is that. Perfect. Now, suddenly, the coefficient of x squared is 2. Factor out. That's what we do. So I'm going to take out the 2, right? Factor out. So this is what I have so far. X squared, I've taken out the 2 minus 10x. I've taken out the 2 plus 47 over 2. I need to explain this. When you're factoring out the 2, you divide this by 2, this by 2, and this by 2. In fact, you can always go back if you want, because if you open up the brackets here, you end up right at this particular point. So now I've got x squared minus 10x plus 47 over 2. Perfect. So I've taken out the 2. I have factored out the 2. Now, guys, please don't make a mistake. There's a fundamental difference between me saying this. Between me saying this is equal to 0. Here, if you want to divide by 2, that's fine. So you end up with x squared minus 10x plus 47 over 2 is equal to 0. You can only do that if it's equal to 0. This is not equal to 0. It's just an equation, f of x. Again, if you follow the rules, I said factor out the coefficient of x squared. And I've factored out 2. 2 times x squared, I go back, 2x squared. 2 times negative 10x, negative 20x. 2 times positive 47 over 2 is 47. I factored out the coefficient of x squared. Why? Because I want to make sure that the coefficient of x squared is 1. Then I follow the rules. There's my 2, perfect, on the outside, x squared, my rule, minus 10x. Take the coefficient of x minus 10 divided by 2 square, add it. Then plus 47 over 2, subtract it. So it's minus 10 over 2 squared, and then that's what you have. Then we do the factorization. Take this first particular part. I still have my 2 hanging outside there. So then I've got my x, put my x there, squared. Take the number in the brackets, don't square it. I have minus 5. And then I deal with this guy here. And when I deal with him, it gives me an answer like minus 3 over 2. Perfect. That's what I have so far. I'm almost to the end because I want it in this format. 2 multiplies inside here. So 2 will multiply this. Now we have 2 bracket x minus 5 squared. This is a question I was answering when one of you guys asked me. So 2 just multiplies on the outside, x minus 5 squared. Then 2 multiplies this guy, negative 3 over 2. At the end of the day, I get negative 3. So this is my f of x, and they wanted it in this particular format. 2x minus 5 squared minus 3, just like that. So this will be the question, how you adapt it, how you play around with it. It's factorization, but we're doing completing the square method. We factored out the coefficient of x squared, which is 2 in this case. Then after that, we did everything that we did in the previous one. Take the coefficient of x divided by 2 square, add, subtract it, then factorize the first guys here, and then it's x minus 5. Check the number in the bracket again. I keep saying this, the number in the bracket and its sign. Do not square it. And its sign, negative 2 divided by negative 10 divided by 2 is negative 5. And then here, these guys, you add them together, negative 3 over 2, 2 multiplies here, 2 multiplies there. Eventually, you're left with that situation. That's basically what you have right there. Right, let me do my last one under this, then I can go to tangents, which is a very interesting part of what we're going to do. I'm hoping that you guys are getting the feel of this, you know, the understanding of all of this, how you play around with this. Let me just unmute someone. Go ahead, you can ask your question.
So sorry, I just want to ask, what happened to the minus 3 over 2 to become minus 3?
All right, perfect. You multiplied. All you did is this. You say to yourself, let me just do it on the side here, 2 times minus 3 over 2. Gone, gone. You're left with minus 3. That's what you did.
Oh, so the 2 of the coefficient of x.
No, 2 is not the coefficient. The 2 of the coefficient of x squared, yes. If you're talking about this part, yes, is the one that
X
multiplies
squared, yes.
minus 3 over 2. And then you end up with minus 3. Yeah, that's what.
So this applies if C is a fraction, like if you have a fraction of 3 over 2.
Yeah.
Or when do you actually?
It applies anyway, even if it was a number. Let me show you. Even if it was a number. So if somebody says 2 as an example, x plus 3 squared minus 4, and I'm multiplying it. At the end of the day, my answer is 2x plus 3 squared minus 8. All I do, 2 times negative 4. Just like I said, 2 times this. So it applies anyway. Whether it's a fraction or not, it's just that here, when I said 2 times negative 3 over 2, I ended up getting negative 3.
Okay, thank you, sir.
Perfect. All right, I'm going on to my next one. Basically, it's the same thing, guys. Nothing out of the ordinary. I'm taking this out. So that's what happens right there. Here's a question again. It's a past exam paper. This one here is from the 2015 Gauteng Prelim question. I think it's question 7.2. And we've got something in this format. I'm going to read the question. Given the equation, f of x is that, write down the function of f in the form that, and hence write down the coordinates of the turning points, and hence write down the coordinates of the turning points. Same thing. It's a quadratic equation. Perfect. What am I looking at? Coefficient of x squared, -2. I need to factor it out. So f of x becomes equal to -2. I hope you guys are working with me in your head. Then I've got x squared, then plus 2x minus 15. That's what I have. So -2 has been taken out. I factored it out. You can always go back if you want. -2 times x squared minus 2x squared, -2 times plus 2x minus 4x, -2 times minus 15 plus 30. I have factored out the coefficient of x squared because I need to deal with my equation when the coefficient of x squared is 1. We do the normal. -2, perfect, there you are. And this becomes x squared, all right, plus 2x plus who? The coefficient of x, which in this case will be 2 divided by 2 squared. And then there's a minus 15 plus who? Plus the coefficient of x, 2 over 2 squared. There you are. -2 is on the outside. I see that. And then you have this and you factorize this part right here. So now I've got x close bracket squared, the number in the bracket and its sign plus 1. Then when I deal with the maths of this one, I get -16. And then eventually the -2 will multiply inside, -2 bracket x plus 1 squared plus 32. -2 times -16 plus 32. They want me to write down the coordinates of the turning points. The format that I know is this one. There you are. That's my format. I need my P, I need my Q. Plus 1 is equal to minus P. So P is -1. Plus Q is equal to plus 32. So Q is 32. My turning points, -1 and positive 32. All right, let me just deal with the guys with their hands. Go ahead. Same thing. I'm about to go to tangents of a parabola. Go ahead.
Hello, sir. Can you hear me?
Loud and clear.
I'm asking about the 2 over 2 on the other side by the -15 side.
Oh, it's supposed to be a minus. Sorry. Yes.
Oh,
yes.
yes. I
Yeah,
wanted to know about
subtract.
it because
All right,
sometimes it's a minus and now you, okay, thank you.
It's a minus. Sorry about that, that mess there. All right. I think that's what the other person wanted to ask as well. Perfect. All right. So you subtract there and you take it up from there. So you add and subtract and you take it up from there. All right. So let me go to tangents quickly. Tangents, if you do your math still, you get -16. Just that I did this before and I was just doing it automatically from my head. But yeah, you get -16. I'm going to my next thing. I want to teach a bit on tangents, then do 2 questions, and we understand all of this. All right, so I'm taking this out. Again, guys, you must know how to complete the square. Whenever the coefficient of x squared is not 1, factor out that particular coefficient. This is very important under this topic, functions and graphs, and you will do this again when you do circle geometry. When you're looking for the equation of a circle, and you're given the standard format of the equation of a circle, and you want to ensure that you change it, and to change it, you need to complete the square. So pretty much the same rules that you will do or are doing here, you will do under that particular topic as well. Let me discuss something here. Here is the story of a tangent. I need to teach you. First thing, a tangent is a straight line. That's what it is. It's a straight line that specifically passes through only one point on a particular graph. So a tangent is a straight line that passes through only one point on a particular graph. The graph that I'm dealing with here is a quadratic graph, and the tangent is a straight line passing through only here, only one point. That's very important to understand. In other words, if somebody was to draw a line like this for me, this line is not a tangent. Why? Because it passes through 2 points on a graph. It's not a tangent. It's a tangent only if it passes through 1 point on a graph. That's a tangent of a parabola graph. Fine. Now, how then do we know the relationship? What is it? Let me give the red graph a name. Let me call it f of x. The quadratic graph, f of x. The tangent, the straight line, let me give it g of x. 2 things we must know. Notice that the point x1 and y1 is the point where the tangent is occurring. This point, x1, y1, is the point of contact between the tangent graph and the parabola. So x1, y1, this particular coordinate is found on the tangent. It is found on the quadratic. So I need to get this right. This particular x1, y1, the point of contact, is available on f of x and also on the tangent. In other words, the point of contact, x1, y1, satisfies the equation of the tangent and also the equation of the parabola. So when I'm talking about the point of contact, I'm saying this x1, y1, if I knew the equation of g of x, this point is available there. If I knew the equation of f of x, this point of contact is available there. So the point of contact acts like a point of intersection, meaning to me, at this point of contact, the equation of f of x and the equation of g of x are the same. One more time, listen to this. A tangent is a straight line passing through only 1 point on a particular parabola or on a graph for that matter. In fact, as a heads up, you will do tangents under this topic. You'll also do tangents under the topic cubic graphs. Again, a tangent is a straight line passing through 1 point on a parabola in this context. The point of contact is the point where the tangent and the parabola meet, x1, y1. This point of contact will be true and available in g of x, the tangent, true and available in f of x, the parabola. That's x1, y1, available in the quadratic graph, the red graph, available in the tangent graph, the blue graph. Meaning to me, at the point of contact, the equation of f of x will be the same as the equation of g of x because they are passing through the same point. The point of contact acts as a point of intersection. That's point number 1. Point number 2, listen to this. Point number 2 says the gradient of the tangent. Since the tangent is a straight line, last time I checked, the equation of a straight line is y is equal to mx plus c, where m would be the gradient of that particular straight line. And since the tangent is a straight line, the gradient of the tangent will be equal to the gradient of f of x. F of x is a parabola. Does it have a gradient? Yes. How do you get the gradient of a parabola? You derive calculus. You derive. So the derivative of f of x is the gradient of f of x. When you derive, I'll show you what deriving means when I do an example. When you derive, so the derivative of f of x is the one that gives you the gradient of f of x, which at the point of contact, at the point of contact will be equal to the gradient of the tangent. Meaning to me, if I know the gradient of the tangent, I know it, then eventually I can also know the gradient of the parabola, because the gradient of the tangent and gradient of the parabola are the same. So listen to this very important information. Number one, at the point of contact, what do I know? That point of contact is available on f of x and g of x, making f of x to be equal to g of x at the point of contact. Number two, what else do I know? I know that the gradient of the parabola and the gradient of the tangent are equal, where only at the point of contact. So it must be clear. It must be clear. The gradient of the tangent and gradient of the parabola are only equal, only at the point of contact. Using this information that I've just talked about, we can now come up with the question and maybe answer a certain question on tangents as well as the particular parabola as can be seen. All right, let's go on that. Let's keep what we've learned in mind and let's go. Here's a question that we're going to do. It says to me, it's adapted from a 2016 Overbeck prelim paper, question 4.3. I'm just going to read the question and then we can answer it together as a team. The sketch shows f of x is equal to minus 2x squared plus 4x plus 6. And g of x is minus 2x plus 6. The turning point of the parabola is 1 and 8. I can even see it on the diagram. Both f and g pass through the point 0, 6. So I'm looking at 0, 6 there. I think that's the point where f and g are passing through that particular point. Perfect. 4.3 then says the following. Determine the coordinates of the point of contact of the tangent to f of x that is parallel to g of x. So I need to read this again. Determine the coordinates of the point of contact of the tangent to f of x that is parallel to g of x. So a couple of things I need to note here. I'm looking for the coordinates of the point of contact of the tangent to f of x. So there is a tangent to f of x. And that tangent happens to be parallel to g of x. Now, notice that the graph of g of x is not a tangent. It's not. It passes the graph at 2 points. So it's not a tangent. But we're told that there is a tangent. Okay, that tangent happens to be parallel to g of x. Fine. The equation of g of x is y is equal to negative 2x plus 6, suggesting to me that the gradient of g of x will be negative 2. Okay, we are told that the tangent is parallel to g of x, meaning therefore we need to understand what is the implication of the word parallel. So I've got my g of x somewhere here. Let me just visualize this. It's my g of x. Then on the other flip side, I have got my tangent. Let me just put it here just as an example. And so I'm learning that the g of x and the tangent, so I'll call this g of x, I'll call this the tangent. I'm just visualizing. They are parallel. According to analytical geometry, and you'll do this as a topic, analytical geometry says two parallel lines have equal gradients. Two parallel lines have equal gradients. Perfect. This means to me that the gradient of the tangent will be equal to the gradient of g of x. So it will be equal to minus 2 because the tangent is parallel to g of x. Very important. So now I know the gradient of the tangent. It's the same as the gradient of g of x because they are parallel and the gradient of g of x is -2. Fine. But I'm looking for the coordinates of the point of contact of the tangent to f of x. From the previous examples or previous, when I was teaching you, I said to you, the derivative of f of x will be equal to the gradient of the tangent. Because the derivative of f of x is a gradient of f of x, it should be equal to the gradient of the tangent. And remember, I am looking for the coordinates of the point of contact. Fine. Now, how do I find the derivative of f of x? It's from calculus. So you say power, which is 2, multiplies coefficient, -2, then power -1. Power 2 multiplies coefficient -2, then power -1. So I'm going to say 2 times -2, I get -4. Then I'll put my x there. Then power -1, 2 -1, that's 1. So I'm going to have -4x for this first part here. Then plus 4x, I need to also find this derivative. Plus 4x, when you're deriving an expression like 4x where the power of x is 1, the derivative is always the coefficient, which is 4. So you'll learn this when we do calculus, just hang in there for now. So now I've got -4x after deriving this one here, or -2x squared. And when I derive 4x, I get a +4. When I derive a number, 6, the answer is 0. So the derivative of a +6, the number is 0. So this becomes the derivative of f of x, but this derivative happens to be equal to the gradient of the tangent -2. Then quickly, I can solve for x. I'm looking for the coordinates of the point of contact. So then I'll have it as -4x is equal to -6. I'm doing some maths. X at the end of the day is equal to 3/2. So what have I found? I have found the x coordinate of the point of contact. I found it. So the point of contact happens when x is 3/2. Right there, I have found it. To find the y coordinate of the point of contact, all you need to do is to take this x coordinate of the point of contact and substitute it into f of x, which is the equation that you know. Remember, you don't know the equation of the tangent. You don't know it. All you know is the equation of the parabola. And so I know that f of x is -2x squared plus 4x plus 6. I have found the x coordinate of the point of contact. I'm intending on finding the y coordinate of the point of contact. So substitute. So we're going to sub x is equal to 3/2 into f of x. Very important, so that I can be able to find the equation, or rather the coordinates of the point of contact. So in other words, all I'm simply saying, I'm saying f of 3/2. So I go back, then I'll put it f of 3/2, the maths, -2, where there's x, 3/2 squared, then plus 4, where there's x, 3/2 squared, plus 6. Eventually, the y coordinate becomes 15/2. And so my point of contact at the end of the day, my point of contact will be for x 3/2, for y 15/2. And that's what you get for your point of contact for this particular graph. Again, family, please remember, I was able to get the tangent gradient by noticing that I'm given the equation of g of x, and the equation of g of x and the tangent are parallel, so they've got equal gradients. So the gradient of that tangent should be the same as the gradient of the parabola. And how do I get the gradient of the parabola? I derive power multiplies coefficient minus 4x and then power minus 1. So I get that. Then I derive 4x, I get 4. I equate it to the gradient of the tangent, solve for x. To find the y coordinate, substitute back into the original f of x equation. That's how you're going to find the y coordinate of the point of contact. Basically, that's what you have right there. That's my first example. I'm hoping that you guys are understanding. Talk to me. We'll take it up from there. If you're not understanding, let me know. I want to do my second example. It's all to do with tangents. I can't overemphasize how important this is. Available on the topic that we're doing now, also available on cubic graphs under calculus. When you're sketching cubic graphs or trying to find the equation of a cubic graph. All right, I'm ready to do another one. My last question on this, I'm ready to try my last question. Let me give you about 10 more seconds to finish this up. We work hard, guys. With maths, you need to work extremely hard. You need to do a lot of questions. The more you do, the more you know. The less you do, the less you know. So I'm intending that you guys work extremely, extremely hard, because hard work always pays off at the end of the day. So the more you work, the more you will know. Here's a very interesting question. I'm going to take this out now. Here's a very interesting question. All right. This is adapted from 2018 IEB March paper 1, question 5D. All right, here we go. Given f of x is that x squared minus 3x minus 6, determine the equation of the tangent to f, which is perpendicular to the line g of x is half x plus 5. Perfect. We're looking for the equation, this time equation of the tangent. What are we given? We're given f of x as this. Then we're told that this tangent, whose equation we're looking for, is perpendicular to the line g of x as this. So I need to get this right. The gradient of g of x is half mx plus c. And I'm noticing that the tangent and the g of x are perpendicular to each other. So what? It means that the products of their gradients will be -1. Where do I get this from? Analytical geometry. So when you've got two perpendicular lines, two lines that are perpendicular, the product, I'm multiplying, the product of their gradients is -1. So the gradient of g of x, I know it. I don't know the gradient of the tangent, but since they're perpendicular, I can find it. So I can divide both sides by half, right? Such that at the end of the day, the gradient of the tangent becomes -2. That's what it becomes. Gradient of the tangent becomes -2 after dividing both sides by half. Okay, fine, good. But I'm not looking for the gradient of the tangent. I'm looking for the equation of the tangent. Now, we need to understand this. Since the tangent is a straight line, when looking for the equation of a straight line, you need two things, right? You need a point on that line, okay? So you need a point on that line. Then secondly, you need a gradient of that line. So we have the gradient, we have it. We've got the gradient of the tangent. So checklist, I have this, it's -2. What I don't have is a point on that line. I don't have a point on the gradient, on the tangent. I don't have it. So how do I get that point? I remember a relationship. I remember that when dealing with tangents, the derivative of f of x will be equal to the gradient of the tangent. The derivative of f of x power multiplies coefficient 2x power minus 1. Then I'm deriving minus 3x is minus 3. I'm deriving minus 6, it gives me 0. So this derivative, all of it, will be equal to the gradient of the tangent, which is negative 2. I can quickly solve for x. There you are. I took minus 3 to the other side. Eventually, x is a half. Now, I've got the x coordinate of the point of contact. To find the y coordinate, like my previous question, substitute into the equation of f of x. So now I'm looking for the y coordinate, f of half. So I go a half squared, then minus 3, then a half here, and then minus 6. And my answer becomes negative 29 over 4. So what have I done? I found the x coordinate of the point of contact. To find the y coordinate, I substituted. So I found the point of contact. When I was teaching you, I say to you guys, the point of contact is a point available on the tangent and also available on f of x. So this point is available on the tangent, yes. It's also available on f of x. It's a point of intersection. And what am I looking for? Go back to my question. What am I looking for? I'm looking for the equation of the tangent. What do I need to get an equation of a tangent? A tangent is a straight line. I need a gradient. Do I have it? Yes. What is it? Minus 2. I need a point. Yes. Do I have it? Yes. What is it? It's the point a half and minus 29 over 4. That's what I have. So the two things I wanted, I have. Now I can get the equation. And because the straight line y is equal to mx plus c. So who is y? Well, it is the y coordinate of the point of contact minus 29 over 4. So now I'm here. Is equal to m. Do I know m? Yes. Minus 2. Do I know x? Yes, I know the x coordinate plus c. Do your maths properly? C is negative 25 over 4. Finally, your equation becomes y is equal to minus 2x minus 25 over 4. That becomes the equation of the tangent. And remember, this time they were perpendicular, and you take it up from there. All right, perfect. I need people to talk to me now. Talk to me. All right, somebody's got their hand up. I'm just going to unmute you quickly. Go ahead.
Sir, can I ask a question in terms of the gradient of the tangent?
Yes.
How did you get the negative 2 from multiplying the tangent and the gradient of g of x?
All right, perfect. So how did I get this negative 2? Let me explain. So basically speaking, you're saying to yourself, just use a black pen. It's gradient of the tangent times half. So it's like gradient of the tangent times half. So it's like times divided by 2. Half times this, right, is gradient of tangent over 2. And then all this is equal to negative 1. Then I cross multiply.
Oh.
The gradient of the tangent is equal to negative 2. Or like I said when I was explaining, you can divide everything by half. You end up getting negative 2 eventually. So that's how you do it. Perfect. All right, let me have another hand. Come through, please.
Say, can I ask?
Yes.
If the tangent was in contact with g of x, we were going to derive g of x instead, right?
If the tangent was in contact
with g of x instead of f of x, we're going to derive g of x
But the
in order
problem
for
is
us to get the x.
okay, good question. The problem is g of x is a straight line. You can't have a
So
tangent on a straight line. Tangents are on graphs which are either cubic or quadratic, right?
So you cannot divide it.
You know, it can't happen because g of x is a straight line. So you can't have a tangent on a straight line. A tangent is a straight line on a curve. A curve can be a parabola or it can be a cubic graph. So you can't have a tangent on a straight line. Tangents strictly are on cubic graphs or quadratic graphs. Hence, you are able to derive the cubic graphs. Hence, you are able to derive the quadratic graph like the examples that I'm showing right now.
Okay,
all right,
and
perfect. Thank you so much. All right, good. So guys, that basically sums up our particular topic for today. And I just want to end it up this way, where I'm saying to you guys, let me just take it up to the part that I want. I'm saying to you guys, okay, guys, like I told you, I'm going to be doing AMA classes. These are Zoom classes, something typical as similar to what I'm doing today. What I did now, I'm going to start them next week. They'll be online, so book your spot. Hurry up because there's limited seats available. Contact me on 073-974-8498 to book your spot right there. Thank you guys for coming today. You guys have been wonderful as usual. I'll see you soon enough, maybe on another free lesson with me, which I don't know will happen when. Soon enough, I'll see you guys. And then I see you guys are going to have fun. I need you guys to work. I trust you. I believe in you. I think with more work, we'll become okay. I'm going to stop recording now and I'll put this on YouTube in about an hour's time or so. You guys can rewatch it anytime. All right, let me stop recording. There we go. See you soon, family. See you soon.